going. All right, so there we go. We got the meeting recording going. Tonight, what we're going to do is we're going to review the rest of the stuff in this class and wrap this thing all up and put it all together. So with that, I'm going to go actually to the modules tab, and I'm going to start scrolling down on the modules because we are here. Technically, I want to say this is maybe the 10th week of school. However, we're kind of finishing up week 8 information. So I'm here on week 8, and I loaded a whole bunch of stuff in here. Everything's pretty much loaded. I have 2 more little discussions that I want to finish up some video footage for, but pretty much everything's there. I even have your final exam loaded, all that stuff. And from this point forward, the class is going to be self-service, and then all the data is there. I'll show you what I mean. So the final exam, it's not due till the end of the semester, so you guys can take this sucker when you're ready. I'm going to go ahead and open it. Remember that this class started off and it was specific, like the curriculum was specifically written for the snap-on meter, right? In fact, that's the title of the class on the catalog. It's snap-on meter certification. Well, what we realized is when we went to do this class distance learning was that we couldn't just be so focused on just the one snap-on meter. We had to set this thing up. Hey, how you doing? We had to set this thing up so that you could use whatever meter you had, whether you had a $500 snap-on meter or a $5 meter from Harbor Freight Tools. So because of that, you know, I kind of rewrote this thing. I even changed like the final to make it more generic, so it would go from any type of meter that you would happen to have. So the idea with the class became primarily get you somewhat competent using a multimeter, right? Knowing a little bit about electricity, knowing how to use a meter, and get that under your belt. And then as a bonus, get certified on Snap-on if that's something that you look to do. So this final starts off with a little bit of basic electrical knowledge. Now, obviously this thing's, you know, open notes, open computer, open books, right? So use all your resources. I'm a big advocate is that, you know, automotive is way complicated to load it all in your head. What I want you to be able to do is to learn how to, you know, find the information you're looking for. So I encourage you to look up the answers to these questions. So here's a little bit of Ohm's law and circuit theory, because we started off our semester talking about that. And then there's some questions about using different tools. I try to put lots of pictures in here to kind of help keep you engaged, and then some ones that are specific about using a meter. Some of them have pictures of the snap-on meter, but other ones use other pictures of meters to kind of give you an idea. So anyways, that's the final. Well, how does the snap-on certification fit into this sucker? Well, if I go back to the modules, what I'm going to do is open up the part of the syllabus where it talked about your grades, and I put a little chart there, and basically it's all points. What do you need to ace this class with 100%? 250 points. So you want to get these points added up. Well, you can see that, you know, if you attended all the Zoom sessions, that would be worth 50 points. The Snap-on certification, that's an extra 50 points. I also had some CDX activities here, which I'll explain those in a minute. But you could decide, oh, maybe you didn't buy that CDX book. You're like, yeah, that thing's too much money. Well, then you can do the Snap-on certification. It's however you want to mix and match these points. I don't care. In fact, what I've also done is added some extra things that aren't even on this chart that give you additional extra points. So it should be pretty easy to total up well over 200 and end up with an A in the class. All right. So all you're trying to do is, get your points tallied up. I've been going through and updating grades today. Some of the things, because they're not due yet, like if you didn't do an assignment, but it hasn't passed the due date, it won't count against you. After the assignment comes due, and if you haven't done it, then you'll see that assignment lower your grade. But so let's get some of these out of the way. In fact, what I want to do is continue to kind of work on some of these assignments to make sure that before we leave tonight, you guys know, what assignments you need to do and how to wrap things up. And you have options, is what I'm trying to get to here, is that you can choose to do this however you want. You could do the activities in CDX if you like those and you have the CDX book. You can do the Snap-on certification if that's what you want to do. It just really depends on how you want to wrap this thing up. So I'm going to go back to the modules tab, and I'll scroll back down to where we were, which was week 8. And so a lot of this stuff is stuff we had already talked about. Like we did all those diagnostics with things like the fuel pump diagnostic case study we went over, and I've added lots of just informational handouts for you. Like all semester long, I've been beating you up about voltage drop. I put together a little handout using some of the PowerPoints we'd used in class about voltage drops. And this handout here will help you maybe on some of your test questions, but more than that, I feel like it will help you out in real life. So it's a PDF, it's thinking about loading. I'm gonna just go ahead and download it to my computer because that'll make it open faster. There we go. And so, these rules, are they hard and fast? Well, they're kind of like my rules, and they have a little bit of wiggle room because it always on cars, it depends, right? Cars are a dynamic thing, but these are pretty good rules to go off of. So I have here, you're testing high current circuits. That would be like a charging system or a starting system. Whenever I'm trying to flow more electrons through the wires, I gotta have a little bit more wiggle room. So my voltage drops that I allow on a high current circuit are going to be a little bit bigger than they would on a low current circuit like a computer. So that's why I made a couple different slides here. So I really don't want to see more than 1 volt drop on the positive side. And I put in parentheses, I really want to see that to be a 0.5 volt drop or less. So here we are with our meter hooked up to measure the voltage drop across the positive side. See, there's a positive terminal of the battery right there. It's going over that charge wire. I would like that to be less than 1 volt and ideally a 0.5 volt or less, right? The lower, the better. And of course, I would do this test when the alternator is charging the battery. So the car is running. And so power, electrons are flowing out of the back of the alternator and going back into that battery to charge that battery back up. You can see on the negative side, my rule here is a little tighter, right? 0.5 volt on the negative side, 0.2 volt or less preferred, right? And if I was going to do that, I'll put up my drawing tools here, and I'll just make the leads blue because I don't really care about polarity necessarily. What I would do is I'd take the negative lead of the meter and I go to just the case of the alternator, clip it on with an alligator clip. You guys know how I like to use those alligator clips. And I put my other lead right here on the negative battery post, and I'd set this thing to volts, and I'd have the alternator charging the battery, right? The car is running, and I want this to be 0.5 volts or less. Okay, that's what I mean by that. Now, why do you think my specification, and really this isn't a spec, it's more like a Mr. French rule here. Why is the Mr. French rule on the negative side a little tighter than it is on the positive side? What do you guys think about that? Why is that? Is it just because I'm crazy? Because I'm prejudiced against the negative side of the circuit? What do you guys think?
Well, you're prejudiced, all right.
About electricity? I'm prejudiced against not looking around for juice, right? Like, I'm a big proponent of, like, hey, look, you're measuring voltage, current, or resistance. You're not digging around for juice on there. You want some juice, go to the grocery store. Okay, so let me ask you guys another question. What is this symbol right here? What does that mean?
Ground.
That's ground, right? We utilize the chassis of the car, the engine block, the frame. We utilize all that stuff as ground to transmit electricity back to the negative post of the battery, right? So unless, and we'll use the body of the car too, unless it's like a fiberglass car, like a Corvette or something. So the reason why our rule is tighter on the negative side is there's a hell of a lot more metal there connecting the negative side of the circuit than there is the positive side. Now, the reason we utilize the metal of the car, right? The frame, the engine block, the chassis, is it saves us wiring weight. We don't have to run nearly as many wires. We don't have to have a wire going all the way to the part and another wire coming all the way back. All we have to do is have one wire to the part, and then the ground side connects everything on the other side, right? So it saves us cost on building the vehicle. It saves us wiring weight. And because there is so much metal on the negative side, it should have lower resistance than the positive side. So our rules for grounds are almost always tighter than they are for the positive sides of the circuit, because we really shouldn't have very much resistance there, because we have the whole dang body and chassis and engine block of the car to transmit that electricity. So that's why we tend to make the ground side voltage drops a little bit tighter. Now remember that voltage drop, VD, that's resistance. And my rule with voltage drop is I don't want voltage drop except across my loads. I expect my loads to drop the voltage in the circuit, not my wiring, right? I don't want VD except across my loads. That's where it's supposed to be. All right. So I also did a voltage drop rule here on this slide for computer circuits, right? So here we are, we're testing a computer circuit. And notice that these are even less because these are low current circuits. I'm not flowing 100 amps through my vehicle's computer system like I am through a starting circuit, right? So maximum voltage drop on the power side, a 0.5 volt. Maximum voltage drop on the ground side, I really want 1/10 of a volt, 0.1 volts or less. Sensor signals, I would like those to be less than 0.2 of a volt voltage drop across those, because there's not very much electricity. There's not a lot of electrons. There's not a lot of amps flowing through those wires. So I shouldn't see a lot of voltage drop. And a lot of our sensor signal circuits, there's not a lot of voltage on that wire anyways. For instance, if I had a oxygen sensor, most oxygen sensors, or O2 sensors as we call them, right? Most of them are a 0 to 1 volt signal. So if I have, any voltage drop there at all, it's really going to mess up that signal and how it works, right? So on an oxygen sensor, 1 volt, if I turn my drawing tool back on, 1 volt tells the computer, hey, I'm running rich. 0 volts tells the computer I'm running lean. So if I had a bad connection on an oxygen sensor signal wire that was dropping, let's say, a half a volt, it would always think it's running lean, and the computer would say, hey, go rich, and it'd really make this thing run poorly. I had a Jeep one time, it failed emissions with 11% CO, which is a lot. It was a gross polluter for nothing more than a high resistance on an oxygen sensor circuit. So that's why we always say get the good oxygen sensors that have like the factory connector. None of this splice it together stuff. That's just going to lead to problems later. So you can see that my voltage drops for low current circuits or computer circuits is much tighter than it is for my high current circuits, right? And that voltage drop itself, it means that if you're dropping voltage, you have a resistance there. And so really what we're doing is we're doing some dynamic resistance testing when we're measuring voltage drop. So I encourage you guys to go through the modules and make sure you look at all these handouts and different things that I put together, because they'll give you more information. Now I know, hey, this thing's only a 1-unit class. However, in the program we are looking at maybe redoing the way that we do electrical in the future, and with that, with redoing electrical, we might actually grow this thing into like a 3-unit class. And if we do, because I've given you a ton of information, I don't mind doing a petition in the future to give you guys more units for this if we do end up growing this class. Because I wanted you to have the information, if nothing else, right? Charging circuit. I put just a diagram for a basic charging circuit to kind of help give you guys some information, right? I used that picture earlier, but here's your basic charging circuit. So, and what the different parts of the circuit actually do. I also have a starting circuit slide. So if I go back here, charging circuit, where did that go? Oh, I'll have to get that loaded up. I thought I had copied it up, but I don't see it. So I'll get that loaded. All right, so there's all kinds of different things that aren't necessarily assignments, but they're things that allow you to get more information from the class. Like if you're ever having to wire up a trailer, right? I'll tell you, trailers seem like they're nothing but wiring problems, to be honest with you, because they get power from the vehicle. You get the connection point of the plug. It can, what type of connector do I have on there, right? Do I have the 4-way or the 5-way? Is it a flat connector? Is it the round style connector, right? The 7-way. So anyways, I have some information here on how to wire up trailer lights and stuff. So there's all kinds of good info here for you guys if you take the time to download it. And what will happen, just so you know, is at the end of the semester, the class will time out, and so you'll lose access to this stuff. So if you want these handouts and different things, make sure you download them to your computer before the end of the semester. Okay. So if we keep going on, you can see that in week 9 we start the snap-on stuff, and all the rest of the weeks relate to the snap-on part of the class. And remember, originally this whole class was focused on just the snap-on meter. Now, a lot of this stuff with the snap-on meter will be pretty easy because, hey, a multimeter is a multimeter, right? Really, it's probably more at the end where we get to some of the extra features, advanced features of the meter that it gets a little bit more interesting. But let me show you how I laid this out for you. Okay. So, you know, for each week, I have a little overview of what's going on, right? And I have information about how you'll do your Snap-on certification. I've added this pre-test, which can give you 45 extra credit points for doing that pre-test. And if you are going to do the Snap-on certification, I strongly encourage you first do the pre-test before you do the main cert. And I'll show you how you get logged in and stuff tonight. All right, so with all that, I give you a little overview. If I go back to week 9, I loaded up the complete manual for the Snap-on meter. It will help answer the test questions. It's a little dry, but you can learn everything you need to learn about how to use the meter technically from this manual. Okay, the whole manual's there. Some of you guys might like to read it that way, and so I have that for you. The next thing I have for you is PowerPoint. I'll go ahead and download this. Remember, you can view it in the screen. It takes a while to load. I'm going to go ahead and download it and open it up. And this is the PowerPoint that Snap-on put together. So if you don't want to listen to me go through PowerPoint slides, you can do that. You can do that by downloading the PowerPoint. Now, it seems like my kids are probably on the internet. They're taking up some bandwidth, so it's taken me a while to download this thing. Because what this PowerPoint is it's the complete, all the PowerPoint for that Snap-on meter. While it's downloading, I'm going to go ahead and go to the next slide here, the next thing that I have on this week 9. And that is a video of the PowerPoint. So basically you have myself or John McCormick, one of our other instructors, reading through the PowerPoint slides, drawing on them, kind of like we do with our Zoom sessions here. So I'll play this.
This is the PowerPoint to accompany the digital multimeter course and also the 596 digital multimeter.
So
measured values will help to.
So this PowerPoint exactly matches the one that my computer is still trying to download. But we've broken it up into 10 to maybe 15-minute segments as we go through these different segments and talk about different things. So I find that a lot of students prefer it this way, but some people just like to look at the PowerPoint slides. And like I said, some folks are just like, hey, give me the manual. I'll read the manual, and more power to you. So there's different ways to learn about the Snap-on meter. You can look at what we have on the screen right here, and what you'll realize is like, hey, we've talked a lot about this stuff already. Ohm's law and how that works, right? Because electricity doesn't matter what meter you're using. It doesn't care about that. Electricity still functions the same way, right? Again, now that my PowerPoint is done downloading, I'll open up that, and I will then switch my screen share so you guys can see it, because it's still trying to open it up. Here we go. It's thinking about it. Okay. And I went ahead and went to the next thing, which is the pre-test. Okay, is the PowerPoint ready to go? It's almost there. I got too much stuff in the way. There we go. Okay. So let me switch. I'm going to switch our screen share to the PowerPoint, and here it is. And remember, we go through this in video segments as well. Now, these particular slides they're talking about category ratings. These ratings right here on the bottom, on this meter, it's got a little thing in the bottom corner where it tells you what the cat rating is. Stands for category, right? And what we say is choose your meter wisely. And so, for example, it gives you some different cat ratings and what they mean and what they're for. If you're going to work on electric vehicles or hybrid vehicles, you want a Cat 3 certified meter. So my little cheapy $5, $10 meter that I got from Harbor Freight Tools or from Amazon or the local auto parts store, that'll work fine for most of your regular car stuff. But I would not trust this. This guy is not safe enough to test hybrid vehicles and high voltage levels. Okay. In fact, now that I've noticed, they're even putting a big warning label on the back that say, "Hey, don't test any voltages over 250." And I don't know if I'd really trust this meter over 100 volts, to be honest with you. So all the information about the snap-on meter is in the PowerPoint as well, and then some. And you can look at just the PowerPoint, or you can watch the video clips. Okay, so you can get an idea how that works. I'm going to go ahead and close that out, and I'll get my screen share going back to the internet. So if I go back, this is the Nc3 Pre-Test. I'm going to go back to modules, and I'm still on this week 9 information. So I'll scroll down to week 9. We basically just took that snap-on and divided it up week to week so that if you wanted to work on it a little bit at a time, you could. But from this point forward, the class is going to be kind of at your pace. So if you're like, I'm going to sit down and burn through all the stuff on the snap-on meter and in one night, you can do that as well. Remember, at first, the snap-on information is going to be kind of the same stuff we've gone over, because a multimeter is a multimeter, but you might glean some nuggets of information that maybe you missed it when we talked about it, or it wasn't exactly clear to you. So it will give you additional insights, like maybe you'd missed that thing on the category rating of the different meters, right? So the snap-on stuff is broke down week to week, but you could just jump from one to the next one. Here's the PowerPoint, here's the video. I have a little overview, and keep going through there. By the time you get into modules 6 and 7, like I'll click this video link for number 6. And in a minute here.
Welcome to Unit 6 on our Snap-on. Welcome to Unit 6 on our Snap-on 590 auto ranging and manual range. It's open, or maybe it's got a numeric.
So we're getting into some more advanced features that are specific to the snap-on meter or a more expensive multimeter. Now, I've been looking at your pictures that you guys have sent me about with your meters, and I got several people with the Harbor Freight meter, which is fine. That works just fine. But I also had several folks that had a more advanced meter that could do things like test diodes or capacitors.
House.
And actually,
air, like let's say you wanted to measure your air conditioning system performance.
This Harbor Freight meter will actually measure a diode, and it has some limited testing that it can do on capacitors, but it also has some features that you're not going to find on something like this, like temperature testing. However, some of you guys sent me pictures of meters that weren't a snap-on one, but they also had the temperature test 6, 7. That's where some of the more advanced features of the meter that I definitely think will be interesting for you. Okay, so if I go back to the modules, and it's taking a minute to load here, but let's go back to the modules and let's get to the end of this sucker. So like I said, you can go do a little bit each week. You can burn through it all in one night. It's however you want to do it. there's going to be a lot of repetition between what's covered in the snap-on or what we've already done. But there'll be some specific things that are specifically how you push those sequence of buttons on the snap-on meter. I skipped all the way down to week 16. How do you wrap this thing up? Well, I have a little outline here, and basically I say, hey, I really recommend you take the Snap-on Nc3 Pre-Test. You can get 45 extra credit points for doing it. Once you're passing the pre-test with the high score, and I would say like you're getting 90% or more, then you're ready to go to nc3certs.com. Okay, so let's check out that pre-test now. Let's look at that thing so you can see what it's all about. So here's the Nc3 pre-test. It still has instructions on how I'm actually going to take my real Nc3 test, but let's take the pre-test. So the pre-test is still on your Canvas website, okay? And if you miss questions, it doesn't count against you. But if you complete the pre-test, you can, get those extra credit points. So you can see it's got all kinds of questions. Some of these are the same types of questions that you have on your regular final exam. I mean, some of these are very basic multimeter questions, like what does it mean when a meter has high impedance? What is that talking about? What do you guys think? Measures a high amount of resistance. What does that mean?
Doesn't it mean it has a high amount of internal resistance?
I got a meter and it says exactly. When we think about it, how do we hook up our meter to measure voltage? We hook it up in parallel to the circuit, right? So if the meter didn't have a high amount of internal resistance, as soon as I hooked it up, that multimeter became a parallel branch, and it's going to screw up the way the circuit works, okay? So the nature of multimeters is when they're set to voltage, they need to have a really high amount of internal resistance. You guys might be thinking, well, why don't they just say resistance then? Why do they say the word impedance? Well, whenever you have electricity flowing through wires, right, it creates a magnetic field around the wires. We've talked about that a little bit. When you take the wire and you make it into a coil, that magnetic field gets stronger and weird things start to happen to make it sound real simple. And so what you end up with is a phenomenon called inductance, meaning that it takes a while for the charge to go through this thing and a discharge because of the interaction of these magnetic fields. Well, because the inside of the multimeter, we know it's not just like wires in there, but there's going to be some coils, there's going to be some electronics. It's not just straight resistance. There is some inductance that takes place inside the meter. So when you take resistance and inductance and you stick them together, that's what impedance is, okay? One area, you guys have probably seen this word impedance before. If you're a stereo head, like I used to be when I was younger, I was all into like high-end audio systems and stuff, and now I'm old and have bills, and so that's I've had to let that stuff go, unfortunately. And too many error tools, I can't hear the difference now anyways. But if you look at the back of your speakers, it'll say, oh, this is has 8 ohms of impedance, or 4 ohms, or maybe you're putting some subwoofers in there, and it's like, oh, well, how much can my amplifier handle? Well, you can justify that and say, okay, well, it's really kind of like resistance, but it's resistance and inductance put together. So anyways, probably more information than you wanted to know, but now you know what the word impedance is really referring to. And you're right, answer C is the most correct answer for this question, right? All of these questions are kind of ASE style, and that means that you really, when you take these questions, you want to pick an answer that you consider to be most correct. What that means is, you might not be crazy about that answer. Like it's not the perfect answer, but of all the garbage you got on that page, it's the one that seems the best, right? You might have a question that you feel has two answers that could be right. Which one would be right more often? That's the one that's going to be most correct, okay? So super important. So here we got two students are discussing connecting the meter to measure amperage. Student A states that the meter lead should be connected in parallel with the circuit. The way I recommend that you take these questions is you take them as two true false statements. So I'm going to look at that statement. Should I connect the meter leads in parallel when I'm measuring amperage? Is that statement true or false? You guys help me out. What do you guys think? Not everybody at once now.
If
Put
you
me on
have
the
it set
spot,
to
aren't you?
amperage and you connect it in parallel, wouldn't it just go around the load and through the meter?
And it would blow your meter fuse.
Yeah.
Exactly. This guy's wrong. So I'm going to put a little F there for false. Good job. Thank you. Student B says that the meter lead should be connected in series with the circuit, and he is correct. So he is true. So then my answer here is B and B only, right? So if you go through this Snap-on pre-test, I'll scroll all the way down here. There's 45 questions on this sucker. Some things are very specific to the Snap-on meter. For instance, the Snap-on meter has an RPM probe, and you can actually use it to pick up your engine RPM and use it as a tachometer. Okay, I don't use that feature that often. Like there's much easier ways to get your RPM, but so there's some specific questions too. How do you use this meter on there? The idea though is that this pre-test is getting you ready to pass the Snap-on certification on Snap-on's website, okay? And so all these pictures are specifically of the Snap-on meter. Let's see if I can find another one where it shows me a different picture of the meter. There's one of the leads on the bottom. So anyways, that's the Snap-on pre-test. It won't count against you, and any questions you get right give you those extra credit points. When you get to the point where you're passing this thing with, a 90% or better, A minus, B plus, something like that, you're then ready to take the real certification on NC3's website. And I've already entered all you guys into the website. So how do you log in? Well, you're going to go to this website and you're going to put in your school email, and then everybody's password starting out is password 1. Okay. So I'll go to NC3 certs, and it's going to log me in right here. It looks like this. Now, it used to just say Snap-on, but what they started doing is they started to partner with other brands. So you can see you have Snap-on, you have Train, you have Lincoln Electric, Starrett. And so then it became the National Coalition of Certification Centers. So there's a little bit more in there. So to get started, you got to log in. Well, I'm already, hot and ready. I'm logged in here already. But what would normally happen is it would say, okay, well, you got to log in. What's your login? It's your school email. So it's your W number, the W, whatever that number is, right? 1, 2, 3, 4, 5, 6, 7, 8, or whatever. apps@losrios.edu. And then it's going to have another box that says, what's your password? Well, your password is password 1. Everybody's password is set the same. And once you get in, you're going to see that you have some options. You don't have nearly as many options as I have because I've done all kinds of Snap-on stuff. But if you've taken classes like with Jennifer Andronis or some of the other instructors, you might find that you have other certifications you can do. But if you're only in my class, the only one you'll see is this 596 multimeter certification. So if you click it, you'll have a thing over here that says, okay, take the exam. I don't know if you'll have the curriculum or not, but the curriculum is what I've taken and downloaded into your Canvas site. So even if you don't see this thing where it says look at curriculum, that doesn't matter. You guys have the curriculum already. So you have 3 attempts. I took one of them and passed, right? So you each have 3 attempts. If you blow through your attempts, I can't like redo it or zero you out, because what happens is Snap-on looks at your name, your name's in there, and your school email address is in there, and they only allow you to take that test 3 times in 1 semester. So next semester you could take it again, but that's not going to help you this semester. So if you want those 50 points from this NC3 certification, don't blow through your 3 attempts. That's why I said make sure you're passing the pre-test and getting an A on that pre-test consistently before you're ready to take the real test. Okay, I'm going to go ahead and click take the exam here. It will save where you're at, but I generally don't recommend like exiting out in the middle, because every once in a while it'll mess up on you. So you know, which of the following 4 diagnostic products is best suited for making exact voltage measurements when pinpoint testing an electrical circuit? And then you got to figure out which one the right answer is. And some of these are, you know, hard, and some of these are pretty easy. We know that the class is all about, you know, digital multimeter testing. So this first one makes the most sense. I would always recommend that you read all your answers available, right? So is a jumper wire going to give me exact voltage measurements? No. If it's fused, will it? No. A non-powered test light? No, none of those things give me exact voltage measurements. So my most correct answer, obviously, is the high impedance digital multimeter. Oh, look at this question. It's very similar to the one on the pre-test, right? So again, if you've done the pre-test and you're passing it, there's no reason why you shouldn't do well on this test, right? So which dial setting will be used to measure RPM with the inductive clamp? So again, that's, I want to say we cover that in like section 6 or 7 on the Snap-on meter. It's also pretty easy to see. Here's RPM. It's got the red line OIP, so that's going to be H, and you could select your answers. That's how you do the Snap-on certification. Take the pre-test, get where you're passing the pre-test pretty well. You'll get bonus extra credit points just for doing the pre-test. Then you go over to the Nc3 website, and I have it all hot linked for you, so you can click the button, go over to Nc3, log in with your student number, and your password is password1, and you can take the exam. When you're done with the exam, you'll be able to print a certificate. So let's see if I can figure out where, okay, so here we go. You'll be able to print out a certificate like this one. You can see I redid that right as we were starting our class to kind of make sure that everything was the same there. So you'll get a certificate just like this. You can save this thing. I recommend you save this PDF, and then you submit this PDF for your class credit to show that, hey, give me those 50 points. I completed the certificate. Okay.
What if I just erase your name and just put my name in there?
Don't do that. Well, I can look in at this thing, you dirty dog. Now I'm going to have to do that for you, Victor. But I can log into the Nc3 and see who's done what. I can't reset you. If you blow through your 3 attempts, you're hosed. It's not an option. Yeah, that way I have a record in Canvas for your class grade. Okay. Also, I'm gonna, well, you'd have to, I'm gonna know because the dates and stuff are different. But anyways, all right. So that's how you do the Snap-on training with Nc3 and do the actual Snap-on certificate. And like I said, as you go through the Snap-on stuff, you will learn more stuff. And you'll see some of those advanced features of that meter, but a lot of the stuff is the same, right? It's not like electricity is working any differently. So it should kind of fold in nicely to our class. All right, and so that's all the way at the end. So in theory, you could probably get that thing done tomorrow if you so wanted to. But you can do that stuff at your pace. Okay. Now, in the past, what I did, how I taught this class, is I'd have people pass the Snap-on test, and then they would come into school and they would take the Snap-on meter and they would show me that they knew how to do certain things. I would say, okay, show me how to test the charging system using that Snap-on meter. Okay, show me how to measure the voltage drop across a light bulb or a relay, or show me how to measure amps of a fuel pump. And so, that gets a little bit harder to do in distance learning, right? So I do have some other assignments that ask you to do those things. So if an easy way to see, like, well, what other assignments do I have to do? If I choose to do the Snap-on stuff, I got that. I know there's a final exam. If you click the assignments tab, you'll see just all the assignments in the class stuff that we've done at this point, like from the SP2 safety test to some of our discussions and stuff. So what do we got left? Well, this is our last Zoom session. So tomorrow I'll get those points loaded in there, and that'll close those out, and you'll see those extra credit points come up. There's a little tiny quiz that helps you prepare for the final and the Snap-on, all that stuff, because a meter's a meter, it all kind of adds together. But there's a little tiny quiz that's only 5 questions about multimeter knowledge. It's called More Meter Knowledge. I'll go ahead and click on that thing just to show it to you. And hey, it's some of the same stuff, right? So if I wanted to measure capacitance, this is a little bit more complicated. Capacitance. So the symbol for a capacitor is the electrical schematic symbol for a capacitor looks like this. And I think, oh yeah, C for capacitor. So if I turn my knob, hey, this is the wrong picture though, because that's not working. I got to fix that, dirty dog. I'm going to turn my knob over there. That means I got to change that picture. Darn it. I put that in my notes. It's always something with prepping an online class. All right. So I got that noted down. So we have a little quiz here to do. Leave that real quick. All right. I'm going to go back to assignments. I'll clear out my drawings. What else? What are some of the more involved things? Well, this one's more involved. Some of you guys already know all the answers to this because you watched the video when we went over it in class together a few weeks ago. But the idea is that if you watch the video, this car has a problem
On the negative terminal,
and you're kind of testing it with me.
in between that 14A to 13A. How did I get there? Instead of just testing at the battery, I have my negative lead at the battery, but I have my positive lead on the positive terminal on the back of the alternator. So that again.
And in the video, I asked you some questions. Those same questions are written down here, and basically you're answering the question. It's the idea is that, normally I'd have you show me how to test something in the shop. And a lot of times what I would do is I would bug whatever you were going to test so it had a problem. and then have you test it and say, well, what do you think about that? What do you think's wrong, right? Well, that's kind of harder to do when we're doing distance learning. So I put together this video. It has a problem. It asks you some questions, and you answer those questions. Pretty, you know, it gets you thinking about stuff. It's fairly straightforward. None of these are like really complicated diagnostics. And we did actually go over the answers in class a few weeks ago. But that's the idea with that. I'll go back to the assignments. Now, all these things are, you know, like, it's not like they're due tomorrow. In fact, a lot of the stuff isn't due for quite a while, so you can kind of do them at your leisure. The charging system one's coming up here. This is the one that's due in a few days. So you don't have to go work on a car or anything. All you got to do is watch the video and answer the questions. What else do we got? We got one on a horn circuit. A few of you guys have already done this one because I was grading some of these today, where you just look up a diagram and you know, look at the diagram for your horn circuit. And the idea is that it gets you testing some stuff on the car. Why do I like the horn circuit? It's not like a critical circuit. Every car should have one. It's usually pretty easy to get to stuff to test it, and it makes noise when you're testing it, so it's kind of a good one to do. I can't stress enough, if you can use a multimeter and you know a little bit about how electricity is going to work, if you can trace a wiring diagram, you can figure out darn near most all of your electrical problems. You really can. I mean, that's, yeah, knowing how electricity works, being able to use a meter, and being able to read a wiring diagram. If you got those three things in your back pocket, you'll be good for electrical diagnostics. So again, if you click the assignments tab, it shows you all the little things that we have. None of these things by themselves are all that difficult. And remember, some of the stuff you can say, you know what, I'm not going to do that because I did the Snap-on certificate, so I got 50 points from that, or whatever. It's you can kind of be the master of your domain and figure out how do you want to rack up the points that you want to get the grade that you want. Okay. I do need to talk about the CDX work. The idea is that this is optional, right? Because you could do the Snap-on stuff, but if you're like, no, I'm never going to have one of those Snap-on meters, and you don't want to do the Snap-on stuff, well, you could do the CDX stuff then, because they're both worth 50 points. Okay. But I wanted you guys who have the CDX book or the CDX online platform, I wanted you to feel like, hey, I'm getting my money's worth out of this thing. And I'll tell you that CDX really does do an awesome job with electrical training. I've just been kind of racking my brain. Like, I was on the phone with CDX a whole lot, trying to rack my brain of how can I put this assignment together? And they have all kinds of stuff on there, but it wasn't really put together in a way that it made it easy for me to grade. So what this assignment is you're going to give me a series of screenshots. So if you have CDX, you log in on your computer, and you're going to do a series of screenshots. Now, you might use like the Windows snipping tool, or you might just hit print screen, but you're going to take a series of screenshots. So this first one talks about going into the electrical section, and you're going to do this anatomy of a car short to power and anatomy of car Ohm's law. So I've loaded, and this is chapter N50002. So it shows you where you're, what chapter you're going to. It's chapter 50. So if I go here, chapter 50, and I go down here to this anatomy of a car, do I want you to do all these? Well, you can certainly do them all because they're pretty cool. Well, I'm only going to ask you to do those two, which, what was it? It was Ohm's law and short to power.
Is that optional?
So this is optional. You could do the Snap-on stuff instead. Because let's say you don't have the CDX book and you're like, well, I don't want to buy that CDX book. Do the Snap-on stuff. It won't cost you anything. Okay. But I do want to show you how cool the CDX stuff is. Like for this one, it's showing us a relay, and you got to put the parts of the relay in the right sections here. And so it's kind of one of these drag things. I'm just throwing stuff in spots. And that is, I guess I'll get stuff in the right spots a little bit better. And it'll tell you how you did. So look at that. I got on, and what I can do is take a screenshot of this and submit that screenshot. Okay. So close that out. Close that out. That one's okay. The Ohm's Law one is okay. Here's my favorite ones. This is awesome. Wiring diagrams. Remember I said if you know how electricity works, you can use a multimeter and you can read a wiring diagram. You are powerful when it comes to electrical diagnosis. So for this, I'm going to go to chapter 51. Okay, so I'm going to get out of here. And I clicked the wrong thing. Let me go back. ASC 6. Okay, chapter 51. And the instructions, show me where this is at. In fact, I'll use it. So N5001, wiring diagrams. Okay, so let me go down there. N5001, okay. And I'm just going to start scrolling through this thing. Okay, and read through, and it's set up to read like a book. It also has the thing where it will read stuff for you. It's got all kinds of pictures. It's got some video clips built in.
Relays are switches that are
how things work, blah, 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 that stuff. I mean, it's pretty dang good. Like, this is a lot of the stuff we've gone over. So what I like about CDX is it's going to take your knowledge to the next level and fill in any gaps that maybe I've left out in our class for you, okay? So that's why I called it CDX Pro work, because if you really want to be a pro, like, and this automotive is new to you, getting access to this will really help you go a lot further in your automotive education. Okay, now what's going on? 0051, did I click the wrong thing? Oh. 0511. I think I'm in the wrong section. Oh, I'm sorry, guys. I clicked the wrong section. Here we go. Using wiring diagrams. So it tells us all kinds of stuff on how to read wiring diagrams, but then it has these awesome activities. So you're going to do two. One is on the horn circuit, and you click it, and you can go through and see how the circuit works. Why is it not letting me do it? I think it's because my annotation tools are. So I can function the horn, and then I can trace it. And see this color code key for tracing the wires? I would use this same color code key in class. In fact, some of you guys, like I think Victor, you probably had electrical class with me. And remember, I'd have everybody bring in a whole bunch of highlighter pens, and I would say, okay, and I'd give you pieces of paper, and I'd have you trace the circuits. Well, now you're tracing the circuits, but you're tracing them virtually, right? So the idea is that you go through and you start to trace this thing out. So
that's a lot better than drawing.
Yeah, no, it's cool, right? So constant ground. Okay, well, that's going to be a constant ground. That's going to be constant. Switched voltage, right? And what do I got here? I got voltage ground, switched ground. I'm gonna go yellow on this, and then I can say, okay, tell me if I'm right or not. Did I get it right? And oh, I messed up right there. See? And then what essentially what you do is you screenshot this, and that's you submit that for your assignment. That's pretty cool. The next one gets even more awesome, in my opinion. Now, we didn't go into this too much. Remember, it's only a 1-unit class. I'm trying not to kill you, I swear. There's 3 popular ways to draw electrical diagrams for automotive use. There's Valley Forge, which is like the American car way. There is ISO, which is like the Japanese car way. And then there's DIN, which is like the European car way. All right. So there's different examples of each one. I only have you do the Valley Forge as part of your assignment, but I wanted to make sure I told you why they have the same. So what they've done is they got the same. This is a HVAC control diagram with the vent actuators and temperature actuators, and it tells you how it works, blah, blah, blah. And then I can go through and I can start tracing the circuit. And if I do stuff wrong, right, I can go through here, and this thing's, you know, it's a pretty monster circuit, but I can go through here and I can do the feedback and see where I've got, where I've done it right or I've done it wrong. Now, if I go out of that one, that's the Valley Forge, right? American car way. I shouldn't have closed that. Hang on. Firing diagrams. I'll go back into it. So let me go to ISO. It's the same circuit. You can see it's drawn a little bit differently because this is the ISO style of drawing the diagram. So I only have you do the Valley Forge way, but I just thought this was pretty cool that they show you what different styles of diagrams are going to look like. And the idea is that they have you trace the circuit. Now, why is tracing the circuit so powerful? Let me go ahead and start tracing some stuff out. Okay. So that's going to be source voltage to the HVAC control module. That says it's going out to the parking lights. So I gotta read those paragraphs of how it works. That's probably going to be some type of switched voltage going to the lights. And some of these things are pretty easy. Like I like to start getting these grounds. I know that's a constant ground, but this other stuff works a little differently, right? Like I have power that goes back and forth to the motor. So, and then I have little sensors that tell me where each door is at, right? So, voltage growth, circuit load, signal voltage. So I can start tracing some of this stuff out. And then I can say, okay, give me some feedback. And you can see what you got right has a little check to it. And what you got wrong has a little X on it, right? Now, why is this so powerful? Because in the real world, if I trace the circuit correctly, I then know how the circuit works. Now I walk over to the car with my meter and I know, okay, on this wire right here, which is red with the black stripe, it looks like it says, I should have 12 volts on that wire. Oops, if I traced it correctly. And with this one, it's ignition switched power. So it won't have power on it with the key off, but when I turn the key on, boom, then it will have power on that wire, right? This one, wire should be a ground wire. And this wire here is a switched voltage at 5 volts. So basically it lets you know what to expect. And then if you test the car and you test that wire there and your drawing, your tracing shows, hey, I should have 5 volts there, and you don't, you know, oh, okay, I found the problem, right? So it lets you know what you should expect to find on the car when you test it by tracing the diagram properly. Okay, so that's the power in tracing the diagram. It helps solidify in your mind how the circuit works, and it lets you know what to expect when you walk over and test it. Now, there's one other cool thing on this assignment related to CDX, right? And that is learning to use the meters. These things are super cool. So there's virtual meters in CDX. So if I go to this one, and I don't know, pick one of these. It's in the thing. It tells me which one to use, but it's got all these virtual meters in there, and you don't have to pick them all. But anyways, it asks you to use some of these. So I wanted to demo some of this stuff. So I click this thing, then I can put my leads wherever I want to put my leads. And I can put that there and that there. I can turn it on to volts. And oh, guess what? It's measuring 12 volts. If I turn the switch on, then the light bulbs turn on. Okay. And it even will do some stuff. If I exit out of here, I'll go to like I'm going to cheat. I'm going to go to Media Gallery because they have all the different multimeter things on here. So I'll just pick one. This will relate to a question that we were talking about before. And it shows you kind of how realistic these things are. I'll turn the switch on. Lights are on, right? I got this sucker set to measure volts, right? What if I decide, oh, you know what? I want to measure amps. So I go over here to amps, and then I go over here to this. Oh, the meter, look at the screen just blew up, right? Realistically, what would happen is you blow the fuse inside the meter, and we've already gone on how to test fuses. Why did my meter blow up? Why did I blow the fuse in my meter when I just did that? What's going on right now, guys? What is going on here? Why would that do that? Let's see, I set it to amps. So I have current flowing through the light bulbs, but now I also have current doing what? It tried to go through here, go in the meter, go through here, and then ground, right? Because I've hooked up my meter in parallel, not series, because I've hooked it up in parallel, and I had the meter set to amps, and I had it in the A hole there, right? When I do that, my meter doesn't have high impedance anymore. Its resistance is very low, and that's why I would blow the fuse. So that's how realistic this little graphic is on how these meters work. And as you saw, there's all kinds of different activities in there to do. I only ask you to do a few of them. I'm just having you scratch the surface, but you would learn a lot by spending time. If you have CDX, spend time and go through all these different virtual things. I mean, they even have ones on oscilloscopes and just all kinds of stuff in here. Current series. I want to see, where's the one with the min max? Oh well. I'm not. I'm not seeing it, but it's got to be in there. All right, so that is the CDX Pro assignments. I know the min-max is in there. Oh, it's under 52002. Describe the ranges. I gotta find this thing. Ranges. Resistance, potentiometers. Oh, they don't have it. Oh, there it is. Learning to use ranges. No, that's not what I wanted. Photoshop. All right, this is bugging me. I have to find this thing real quick. 52002. I thought it was really cool because they actually have a Hall sensor in there that's working correctly. Okay, so there's that one. Scroll down. Min max. I don't know why I couldn't find it in the other spot. Here it is. So here I have a Hall effect switch, and if I somehow it shows me a little bit about the electronics, which is really cool. If I turn my switch on, I can run the engine. This would be like your crankshaft position sensor. And so the engine's spinning, and then that's generating that signal. All this is drawn correctly of how it's like wired up in the computer and how the computer's looking. And so this is pretty neat how they put this all together. So if you have CDX, I really encourage you to use it, and you'll get some points for it. And more importantly, you'll learn a lot by doing that. So that's what the CDX Pro work is all about. Okay. So I also have a little course wrap up for you to do at the end of the class, and that's pretty much it. We got the pre-test on there, a few little hands-on things where you're using the meter to test stuff that's easy, like a horn relay, or here's one on testing fuel pump. And the whole idea is to get you doing basic tests with your meter to make sure that you know how to use it. So even though we're not going to have Zoom sessions, if you email me, you can put stuff on the chat. You can also go to the discussions and go to the tech help. If you have issues, throw that stuff up on there. Give me a little bit, because I might miss it. It might take me a day or two, but I'll see it and I'll get back with you and we'll answer your questions. In some cases, what I had to do is make another little video clip and send it back to a student or different things. But you'll be able to get through this stuff, and in some ways, you guys might end up learning more through this than in other classes I've had before. Okay, because those of you who have been in the auto program, you guys know how it is. Like, you're in a group, 3 or 4 students. There's always that one guy in the group who's just kind of cruising, writing down what the other guys are writing down. Well, when you're doing it on your own, right? When you're doing it distance learning, you can't be cruising off the other guy, right? You have to look the stuff up and learn it. So you're under the gun, so to speak. And I'll tell you, when you go to work on cars in the real world, there's nothing like that rush of adrenaline when your boss says, okay, well, that thing's in here for a no start. You figure out what it is, right? Oh, crud, what are you going to do now? It's just you. You got to figure out what to do next on that thing, right? So you know, in some ways, I'm kind of excited about seeing how you guys go through this stuff in this course, because I think if you really do these things, you do the CDX activities, you go to do some of these hands-on things, you'll learn a lot. Now, there's way more points. There's like, you know, 350, probably almost 400 points available in the class. You only need a little bit over 200 to ace the class. So you guys can kind of pick and choose how you want to do that stuff. But remember, if you do all the stuff that we presented, you will have learned a ton of stuff. And I can't stress enough, if you know how electricity works, you know how to use a meter, and you know how to read a wiring diagram, you can do a lot of electrical diagnostics. Okay, so with that, what I want to do now, that I've kind of summarized everything we have left in the class, is I want to show you some stuff that we'll have going on next semester. So let me see if I can put that up. I accidentally had closed that, close what I wanted. And you guys will probably see a flyer being sent to your school email here pretty soon, because I'm working on it with our new office person, Andrea. It's thinking about it. It's loading. All right. So next semester, the classes that are new and big. Let me make sure I'm getting this on the screen share here. No, I'm not. See, there it is. The classes that are going to be new, that we haven't ran in actually several years, are this AT-143 Automotive Parts and the AT-146 Automotive Service Consultant. So if I scroll down here, if you've taken AT-100 and 105, if you've taken these classes and like AT-180 this semester, if you partner those with the service advisor and the automotive parts class, we have a certificate that's automotive parts and service. You can get that certificate, okay? And I will say that, man, the parts business is busy right now. They are slammed. So there's definitely jobs needed there. And then for service writers, and every shop seems to need a service writer. That's the person that greets the customer, brings them in, writes up the repair work. If you're good at dealing with people and you can manage, workflow, and you can explain how things work, there's a future for you as a service writer. So we're going to get these classes going. We haven't ran them in several semesters. We're excited to run those classes. This is the class, of course, you guys are in right now. But if you want to continue on the diagnostic side, I would say your next logical step would be the 188. Now, the class, kind of like we did with the meter, originally it was written just focused on the snap-on meter, right? This class was originally written and it was focused on the snap-on Solus. That's why the title on our website is going to say snap-on Solus, right? But what I'm doing with this class, just like I did this semester, is I'm basically remaking it so that it's get the most from whatever scan tool you have. We're going to put together some scan tool kits where basically we're going to be just using little OBD2 phone dongles, and I'll be going over everything about what onboard diagnostics is all about, to how to get the most out of a generic low-cost scan tool, and then we'll mix in some of the stuff that the high-end, the snap-on tools and stuff can do. So, but just to kind of give you a precursor to that. Oops, you guys can't see that screen share right now, I don't think. There we go. Sorry, guys. So there's one of these little cheapo dongles that would use your cell phone. So we'll have some of those for you guys to to get from school. I have like one of them right here. You know, and they basically give you generic OBD2 information, but there's a lot of information that you can glean. There's a lot of diagnosis you can do with that. And so that'll be the idea, that that class will go over a lot of the basics of onboard diagnostics and scan tool diagnostics. And we'll also look at the snap-on one, but we'll really be focusing on leveraging what you can do with leveraging the. All right, so let me switch my screen share again. Okay, so let me switch my screen share again. And I do want to say one thing. When it comes to scan tools, right? If the mill light is on, if the check engine light, service engine soon, or mill, whatever the heck you want to call it, if this light is on the dash, what that basically tells you is the computer in the car is pissed off about something, right? In some ways, if the repair order says, hey, your job is to figure out why the light's on, diagnose that, what you're really trying to figure out is what's the computer pissed off about, right? What's making the computer fail a test and turn that light on? And for that, you need a scanner. And how we kind of look at scanners, and this is a snap-on thing, but I really like it, is a scanner is kind of a directional tool. It's going to set codes. It's going to give you some data. It's going to send you hopefully in the right general direction, but you're still going to pinpoint diagnose what's wrong with your meter, right? It's still up to you to use your meter to pinpoint what's wrong with that circuit, okay? So that's that 188 class. You know, and we'll see how that goes. I mean, all this distance learning stuff has made me think, man, you know, it would be neat to have a, I closed it. It would be neat to have like an oscilloscope class, but unfortunately there isn't really AES way. There isn't really inexpensive oscilloscopes out there. About the cheapest oscilloscope you're going to find that's decent for automotive testing would be this little scope right here, this U scope. And you can see it's not bad. But it's not super cheap either. I'd like it a lot better if it was like $69 instead of $169. But it is a nice little one-channel scope. Anyways, it has me thinking about the possibilities. You know, when you look at an oscilloscope, essentially it's a multimeter, but instead of just, you know, giving you numbers on a screen, it's able to graph that voltage out over time, right? So what I like about oscilloscopes is not only are they faster than our meters, but in some cases they help me figure out how a circuit works, because I can see what the voltage is doing. So remember, scopes, multimeters, those are for pinpoint diagnostics. Things like your scanner is to get you in the general direction. The 188 class next semester is all about getting you going in the right direction, okay? So all the classes we have on the books for the spring right now are right here, from AT-100 basics to employability skills. I already mentioned the parts and the service class, to the Solus diagnostic scan tools class. Those are what we have on the books right now. I just had a meeting before our class started with some of our vice presidents and stuff, and they know that we really want to get back to hands-on training. but there's a lot of stuff that's unknown. There's a lot of stuff that's kind of totally out of our control, right? So it's going to have to depend on what the infection rates are for COVID in Sacramento County and lots of things. But we are looking to see, can we get some classes going again in the second half of the spring semester, right? Like second 8 weeks or third 5 weeks. So if we can do that, we will. What classes will we offer? Well, what we're going to do is we're going to look at all of our students and figure out what students need what hands-on class to graduate and stuff. And those are the classes we're going to focus on first. Depending on how that goes, we're going to try to have a strong summer semester, like more classes ran in the summer. And then, add some more classes, have a strong fall of 2021. A lot of this completely depends though on what happens with the COVID pandemic and how our infection rates go. And here in California, we're doing pretty good so far. It looks like according to the news, a lot of other states are not doing as good as we are here though. And if that happens here, then some of these things could change. But I just want you guys to know that myself and all the automotive instructors and the people above us and our administrators are committed to trying to get hands-on classes going as soon as we can. What we don't want to end up with is classes starting and stopping. And we have had that, seen that happen in some of we tried to keep our medical courses going, like our nursing program, and had to start and stop and stuff because in infections, people were exposed and you have to do a quarantine, and if you end up having to stop class in the middle for a quarantine, at some point you may not be able to finish the class because the college curriculum is pretty strict in that you have to meet for X number of hours for instruction. You have to meet these minimum hour requirements for a class to count, and we don't want to get in the situation we were in the spring of this year where we had students that couldn't finish their courses because they just hadn't met for enough hours. So anyways, I wanted you guys to know what the schedule is going to look like. It just popped up online, so you can view it online as well. I might move some teachers around from different spots, but it's pretty solid on what you're going to see with the schedule for the spring. So you can see what's going to be on there. Right now it's all online, but we're really hoping to get some hands-on in-person classes going for the second half. But we'll see. There's a lot yet to be determined. So I hope with that, it gave you, a good overview of the class. I always like to finish things off with some tech tips. And so I will do that now. I'm going to switch this around and change my screen share one last time. And we're going to get this stuff out of the way, and we're going to finish this thing up with some tech tips. Okay, I got my document camera going here. And in a minute here, there we go. We should see some stuff on the screen. Sure, I can draw on the screen, but oh, let's see what's going on here. My camera's not plugged in, guys. Too many wires on this table. Plugged in here. There we go. Sorry. All right. So, got my document camera. I got a few things up on the screen here. Again, these little Harbor Freight meters, little cheapy ones that you can get on Amazon and stuff, those work pretty well. I would not trust this on a hybrid vehicle, right? I wouldn't trust it for high voltages, but it's a good like backup meter to have. Maybe you throw it in the glove box of your car. One thing I don't like about it is the leads don't transfer between this meter and a real professional meter, right? It's just a little bit different, and usually the leads don't quite plug in the same. But for a lot of testing, that guy will work just fine. Now, I like the back probe stuff with T-pins. Sometimes that's just not available, and I know some of you guys in the field use these insulation piercing probes. I wanted to show this to you. This is that you can poke through the insulation of the wire, right? It's got a little pin in there that screws and pokes through the insulation. If you're going to use something like that, well, one, I don't like using it a lot because it might allow you to take a reading. However, later on, that could lead to resistance and lead to a problem. If you're going to use something like this, at least cover up where you prick the wire with some dielectric grease, or maybe some liquid electrical tape or some conventional electrical tape, or even some heat shrink to protect those wires when you're done, okay? For the most part, I'm not a huge fan, though, of these insulation piercing probes. However, sometimes that's what you got to do because you don't have a better way to do it. So I got one other tool that I was talking about. Here's our digital storage oscilloscope. It basically is the same as this, except this is faster and it can graph out what's on the screen, right? That's the big advantage. The downside is that these are expensive, right? The cheapest one I showed you cost $160. So I noticed that some of you guys, when you sent me your pictures, you had meters that could measure temperature. They had these little temperature probes. And these are pretty sweet. You can do a whole bunch of tests if you have a meter that can measure temperature. Now, our snap-on meter to measure temperature requires that adapter thing, which is fine. And if I want to measure temperature, I put it in the temperature probe like this. And I go over here to temperature, and I can select Celsius or Fahrenheit, and I can take the end of this little probe and touch it to whatever I want, right? So if I put it in my hands, you can see the temperatures going up, okay? Do you have to have that? No, but sometimes it's nice. For instance, give me an example of why I want to be able to measure the temperature of something. And why do you think this probe set up how it's set up? Cut my zip tie off of here, without cutting my wire, hopefully. Well, what if you have a car where the temperature gauge on the dash says this car is overheating? It's in the red zone, okay? But the car doesn't seem like it's running that bad, right? If you have a car in for an overheating issue, what you could do is you could loosen the upper radiator hose. You could slide this guy down that upper radiator hose, put the clamp back on, and run the car with this little tiny temperature probe inside the radiator hose, measuring the temperature of the coolant, and see what the real temperature is of the coolant in the engine, right? So that would be one example of using that temperature probe. I
You
used
can't
to
do it
put
on a
this
Beamer.
it'd be harder to do on a Beamer, right? You have to get something where you can slip this guy underneath the hose there. Before infrared temp guns were so common, I had a probe like this, and I would take some long pliers and I would stick it up against the front of the catalytic converter and the back of the catalytic converter to see if the catalytic converter was working. So there's lots of times where having a temperature probe like this works pretty good. Another place is, let's say you're doing air conditioning work and you want to performance test the AC system. You can stick this down in the dash vents and measure what the temperature is coming out of those vents. So there is some reasons why having a temperature probe on your meter is kind of handy. But it's definitely not like a must-have thing, but I wanted to give you a few examples of that thing. Okay. Remember the themes of the class. If you know how electricity works, you know how to use a meter, and you can read a wiring diagram, you'll be able to do a lot of diagnostics. Another theme of the class is that whenever possible, test dynamically, okay? Remember, when your meter is set here to ohms, and I've demoed this before, it can't tell the difference between this wire and that wire. They're both going to test out at like 0 ohms or 0.1 ohms, right? So test dynamically, don't test static. Let me give you another example of that. I can't remember if I've given you this example before or not, but we'll do our tests here just the same. I'm gonna take my two. I plugged in some leads to this meter. I'll hook them together. It says 0.2, 0.3 ohms. I'll hook it up to these little. Now I got a 0.09 ohms. All right, I'll do the same thing on this other wire. And I bet it's going to be just about the same as it was before. 0.05. It all depends on how good of a connection I get on the end. So remember, don't test statically with just an ohm meter because it's not going to give you realistic numbers. Here's another kind of static test. Measuring spark plug wires. The specification is a maximum of 1,000 ohms per inch. I have a spark plug wire here that's, I don't know, 12 inches long. I shouldn't have any more than 12,000 ohms. This one only has 4,000, maybe 4,500 ohms. So that thing passes that test, right? But I could have a spark plug wire that's shorting out to the side of the engine, causing problems, causing a misfire. A much better test would be a dynamic test, right? And an example of a dynamic test would be for me to put a spark tester on the end of this spark plug wire and make sure that I had a good bright blue spark coming out of the end of that wire like I should have. And somehow my spark tester moved away, but you get the idea. So remember, next semester, we'll be looking at onboard diagnostics. That's what that OBD stands for. And we'll be using inexpensive OBD testers like this one right here to pull generic OBD2 data from the car and how and really focus on how much I can leverage that data to work in conjunction with my multimeter to diagnose a lot of drivability problems on your vehicles. And then we'll show you some stuff on what the Snap-on Solus can do that maybe you can't do with one of these guys. But that'll be what the 188 class is all about next semester. So with that, what I'm going to do is I will switch this thing back to the computer and basically just wrap this this Zoom session up. Hopefully, oops, I'll leave the student view. Hopefully you guys have gotten some information out of this class. It really works twofold, right? If you are in the class and you hadn't taken electrical before, the idea is that this class would have given you some basics of electricity, how it works, reading diagrams, and how to use a meter, right? For those of you who have done electrical before, maybe you're in the field, the other goal of this class is just provide you with a really good review of a lot of these concepts that will make you better at doing diagnostics on the vehicle. Remember, we went over this by tracing circuits and talking about how things work. A big part of diagnosis is knowing how things work, right? And you ask yourself, well, what is this thing supposed to do? And is it doing it, right? That's kind of our KISS formula, or keep it simple formula to diagnostics. What is it supposed to do, and is it doing it? So with that, if you guys don't have any more questions, I will I'll let you go and let you get back onto your normal lives. Remember that we have the tech help here on the discussions tab. To help you, you can always click the little email box. You could send me an email. There's all kinds of ways that you can get a hold of me, and if you get stuck on anything, email me stuff. If we found tonight, I have notes down where I found an assignment that had a question that was wrong. I'll get that question fixed. If you have an assignment where it doesn't let you post the thing, remember this is the first time we put this class online, so it's the first run through for a lot of this stuff. Sometimes I'll test stuff at home and it works on my end, but I realize, oh, it doesn't work on your end. So if you're having problems with getting the assignments to submit to something or get it submitted, make sure you get a hold of me and I'll get that stuff fixed. If we need to, I'll extend out the due date and we'll get stuff dialed in for you. So I hope you've enjoyed the class, and I hope to see you again in another class next semester, perhaps the scanner class or some of the others. And you know, just keep learning and keep having fun. All right. Stay safe, everybody.
All right, good
I'll let
night.
you guys go. Take care, everybody.
Bye.
Don't be afraid to, you know, ask me questions if you get stuck on any of your assignments. Okay. All right. Take care.